Hi, Pre-Calculus Honors. So these are notes for section 1.4, compositions of functions. We have two objectives for today. We're going to be able to build new functions by adding, subtracting, multiplying, dividing, and composing functions. And we are going to be able to define the domain of these new functions built by adding, subtracting, multiplying, dividing, and composing functions. So go ahead and take a look at that blue box. Pause the video for a minute and look at the blue box and just go ahead and read through what is going on with these functions and each, the sum, the difference, the product, and the quotient. Okay, so let's take, for example, the sum. If we consider the plus in the expression f plus g of x, the function addition builds a new function f plus g from the given functions f and g. F plus g takes a domain value x and returns a range value f of x plus g of x. So the domain of the sum, difference, product, or quotient is not always obvious from looking at the new equation. We have to be careful. So let's consider the following example. So if you're given f of x and g of x are both radical x, we're going to find f times g of x and the domain of f times g of x. So go ahead and pause the video and go ahead and see if you can find it. Okay, so when you take the product, you have radical x times radical x. You have to be very careful. Let's consider the domain, okay? The domain is not all real numbers. The domain of f times g is 0 to infinity. Look at f, look at g, they both have a domain restriction. We have x greater than or equal to 0. So let's use our graphing calculator to help support this. So the domain is 0 to infinity. And if you take a look at your graphing calculator, I type that in and look at the graph, notice that it does indeed preserve that domain restriction, that if you have radical x times radical x. So again, you have to be very careful. So now let's consider composition of functions. So if we have two functions, f and g, and we'd like to take their composition, first of all, there are different ways to write this. I've seen it f of g of x written like this. I've seen it f of g of x written like this, but it's very, very important. It does not mean f times g. Okay, so this is a composition. The domain of f of g consists of all x values in the domain of g that map to g of x values in the domain of f. Again, that's kind of confusing. Let's do an example. The first thing you might want to do is think about what makes two functions equal. Two functions are equal if they have the same domain, and for each value of x in the common domain, the two function values are the same. So let's take a look at these two examples. They both have, f and g both have a domain of all real numbers. And let's go ahead and find f of g of x and g of f of x. So go ahead and pause the video and find each. Okay, let's see how you did. So if I would like to find f of g of x, notice my f, the g is on the inside of these parentheses. So I take f, and everywhere I see an x, I'm going to replace it with all of g. So it used to say f of x, but now it's f of g of x. So all of g is put into those parentheses. I have 2x squared. For g of f of x, I have x is squared. So we're not using x anymore, we're using all of f. So all of f would go into those parentheses, and we end up with 4x squared. Okay, so now what I'd like you to do is think about, again, that we compare the domains, but now let's use our graphing calculator to take a look at these two functions. Okay, so in y1, I typed in 2x, and in y2, I typed in x squared. In y3, I want y1 of y2 of x. So let's take a look at the graph, and notice, there you go. Oh, let's stop that for a second. I turned off by unhighlighting, if that's a word, the equal sign. So I just want the y1 of y2 of x, and so here you go. So this is f of g of x. And if you wanted to know, for example, a specific point, you could go ahead and do that now. What I would like you to see, though, is how I was able to type that into the calculator. So I'm going to go to y equals, and let's say I wanted g of f of x. So I will temporarily, actually we could leave that on. I will type in, I go to vars, y vars, function, go down to y2, yeah, that was our g, then a parenthesis, then go back to vars, y vars, function, y1, parenthesis x. Okay, so now we are going to have the black function will be f of g of x, and the pink will be g of f of x. There we go. So they're definitely not the same function. Okay, so let's do the next example. Go ahead and see if you can find f of g of x in the next example. Okay, so now we're looking at number 3 and number 2. So we had f of g of x and g of f of x had the same domains, but definitely different functions. Now we have f of x and g of x. And notice when you want to find f of g of x, you would say, well, f of x is radical x. So everywhere we put an x, now I'm going to substitute x squared. And in g of f of x, I take the function g, and inside those parentheses, I'm going to put f of x. So if you think about this, maybe some of us have forgotten this, but the square root of x squared is actually, the square root of x squared is the absolute value of x. And over here, if we have square root of x squared, we have x. But again, we have to be really careful about our domain. So let's think about how you would find the domain for each. Let's first of all find the domain for f of g of x. So it helps, I think, to consider the domains of f and g. The domain of f of x, notice x has to be greater than or equal to 0, and g of x is all real numbers. So that means if I'm thinking about the domain of f of g of x, f requires that all of its x's, every input value, is greater than or equal to 0. But again, our input now is all of g of x. So x squared must be greater than or equal to 0. And the range of x squared is the values from 0 to infinity. We would also have to consider that g of x, the input values for g of x are all real numbers. And so that's why the domain for f of g of x is all real numbers. Now, if you wanted to find the domain for g of f of x, again, this time we're thinking about g. G requires that all of its x's, all of its input values are real numbers. But if you think about it, however, consider the domain of f. The input values for f must be greater than or equal to 0. So again, I'm expecting the domain of the composition to be 0 to infinity. Now, it might help if you are trying to find the domain of a composition to look at your composition before you simplify. And I think that it would be more obvious if you look here and realize, oh, I do have a domain from 0 to infinity. Let's go ahead and check this on the graphing calculator. Okay, so I graphed radical x, which was f, and y1, and I graphed g of x, which was x squared, and y2. So if I have y1 of y2 of x, that's f of g of x, and let's see what the graph would look like. Oh, I turned everything on. Okay, sorry about that. Let's just turn on the f of g of x. So if you take a look at f of g of x, there you go, which is just as we expected, the absolute value of x with domain of all real numbers. Let's go ahead and take a look at g of f of x. So now I've turned on y2 of y1 of x, so that's g of f of x. And again, we are checking our answer. We had a domain of 0 to infinity for this one. Let's see, because again, our graphing calculator will preserve domain restrictions, and you end up with, there you go, 0 to infinity. All right, nice job, everybody. Let's move on to the next example. Okay, let's keep practicing with composing functions. So again, I think it might help if you consider the domains. So f of x, go ahead and write down the domain for f of x and the domain for g of x. Pause the video and then check your work. Okay, so remember, it would just be a pure coincidence if you put the domains together for f and g and said that was the domain of the composition. That would just be a coincidence. It's a little more complicated than that. So let's go ahead and find f of g of x, and then we can go ahead and find the domain. So if we take our function f, and instead of placing x in the function, we are going to replace the x with all of g. And again, we talked about this earlier, that it probably helps when you're considering domain to not simplify, okay? So notice that f requires that all of its x's, its input values, that x is a real number. However, g of x is now going to be our input values. And if you think about it, the domain values for g of x are greater than or equal to -1. So therefore, so let's see, g requires that x, or f requires that x is a real number, right? And g of x right, has domain -1 to infinity. So our domain of our composition is -1 to infinity. And again, you could check that on your calculator. But again, I think if you look here, it would have been easier to find the domain if you don't simplify before you consider that. Okay, so what we're going to do right now is we're going to do something called decomposing functions. So I would like you to take a look at number 5, and actually you won't necessarily have a unique answer, but I would like you to try and find two functions f and g that will give f of g of x that's given there. Go ahead and pause the video. Okay, so do you see how this is kind of like we're having a scavenger hunt here? You have to kind of recreate the scene here. We have to figure out what's going on. So f of x, if you have f of x is x squared minus 3x plus 4, and g of x equals x plus 1, notice when you find f of g of x, so let's just start over here, you would say, well, let's take f, let's test out and see if our hypothesis works here, and everywhere you see an x, we're going to replace it with all of g. And there you go. Okay, so why don't you try the next one? Now the next one will be a unique answer because I gave you everything but g of x. So again, the first one, someone might have looked at different ways to compose the function, but I feel like what I chose might have been the most obvious from what I gave you there. Go ahead and try number 6. So pause the video and try to come up with a function, g of x, that would make f of g of x equal to what is given. Did you get g of x is 3x squared? Let's go ahead and check our hypotheses here. So if I have f of g of x, so again, pretend I can't see that right now, and I'm going to, everywhere I see an x, I'm going to replace the x's with g of x, and my hypothesis is 3x squared. So now in f of x, I have 1 over, I don't have x minus 2, but I have 3x squared minus 2. So notice that is what we were asked to do. So g of x equals 3x squared would work. Okay, so we're actually going to stop the video there, and we're going to do the rest of these examples in class. Have a great day, everybody.